Hello everyone. In this video we'll be going to discuss about the properties of subtraction of integers. Let's start. So here we have the first property, that is closure property of subtraction. Now again the closure property is, suppose if we have a bag with full of integers, and if I just take out one integer and one more integer, and if I just subtract them, then we have to check that whether the result is also integer or not. Now if a and b are any two integers, then a minus b is always an integer will be. Now here we have, let's say, one group we have, and then we have the another group for integers, and now if we subtract them, so the result will be also, it will be an integer. Let's try to take one example. Let's say if we'll have negative 5 minus 10. So after the subtraction, the result will be negative 15, which is also integer. We can take one more example here. Let's say negative 8 minus negative 7. So if we will simplify this, so we know that this negative and negative will become positive. So the final result will be negative 1, which is also integer. So if we subtract any two integer, we'll get integer only. So we can say that it follows the closure property. Now let's have the next property. So subtraction of integer is commutative or not commutative, that we have to check, right? Now commutative means if we change the order, let's say if we are subtracting a minus b, and if we do b minus a, are we getting the same answer? That we have to check. So let's say here we have a as 3 and b as 1. So a minus b, so a minus b we are solving here. So 3 minus 1, here we are getting 2. Now if we do b minus a, b minus a, so 1 minus 3 I have to write here. So 1 minus 3, and the result is negative 2. So what we can conclude from here, that is a minus b is not equals to b minus a. So subtraction of integer is not commutative, right? Because the value is not same, the final answer is different if we change the order of subtraction. Now let's have the next property. Subtraction of integer is associative or not associative. Associative means we are grouping in different pattern or in different order. So here we have a, b, c. So we have to check. So first the group will be like a minus b minus c. So let's do it. Now 2 minus 1 and minus 5. So the result will be 2 minus 1 is 1 and 1 minus 5, that is negative 4. So here we are getting negative 4. Now we have to change the grouping or the order of grouping. So it will become a minus b minus c, right? So first we used to group a and b, and c will be separate. And on the other side, first we'll group b and c, and a will be separate. We used to group a and b, and c will be separate. And on the other side, first we'll group b and c, and a will be separate. So that is a negative 4 and 2 minus negative 4, right? So that will become 1 minus 5, that is a negative 4. A minus b minus c is not equals to, our predecessor is a, let's same. So what we can say, a minus b minus c is not equals to a minus b minus c. So subtraction of integer is not associative, right? Because the answers are not matching. Now let's discuss one note here. So here we have a successor is a number that comes after a given number. Let's take one example. Suppose if we have here -7 and we want to find the successor of -7. So what we have to do, we always do +1, right? So to find successor we do +1. So for -7 also, so we'll do -7 plus 1, then we'll get -6. So what we can say that successor of -7 is -6. Now here we have the predecessor. A predecessor is a number that comes before the given number. It means here you have to do -1. Let's take the same example. So here we have -7. Now to solve this, we have to do -7 and -1, right? So when you will simplify, we'll get -8. So the predecessor of -7 is -8. Now let's try to solve some questions based on this. If a is equals to 8, b is equals to 5, c equals to 2, verify that a minus b minus c is not equals to a minus b minus c. So let's plug in the value. So 8 minus 5 and minus 2, that we have to simplify first. So 8 minus 5, that is 3. So 3 minus 2, we are getting 1. Now on the other side we have to check for a minus b minus c. So a minus b minus c. So when we'll simplify it, so we'll get 8 minus 3, and this side will be getting 5. So here we are getting 1 and here we are getting 5, which is not equal. So definitely we can say that a minus b minus c is not equals to a minus b minus c. And which property is this basically? That is we can say that like integers are not associative for subtraction. Now let's have the next question. So here we have the question, write 3 integers just preceding -4. It means we have to find 3 predecessor of -4. So let's solve it. So we have here -4. Now to find predecessor, we subtract 1, right? So first predecessor, that is -4 minus 1, that is -5. Now in -5 we will subtract one more to get the second one. So -5 minus 1, that is -6, and for the third one -6 minus 1, that is -7. So here we have -5, -6 and -7, which are the predecessor of -4. So the answer is correct. Now let's have the next question. Write 3 next successor of -2. So to get the successor, we have to do +1, right? So first successor, so -2 plus 1, that is -1, and second is -1 plus 1, that is 0, and the third one is, that is 0 plus 1, that is 1. So here we have -1, 0 and 1, which are the 3 successor of -2. So that's the answer. Now let's have the next question. Find the smaller integer and write its predecessor. So see, we have one trick to identify like which is the smallest one, right? Now imagine if we have the number line, right, for -11 and -13. So we know that -11 will be somewhere here and -13 will be here. Now to identify which of them will be the smaller, now remember that the number which is closer to 0 will be bigger, right? So let's say here we'll have somewhere 0, right? So negative 11 which is closer to 0, it means this will be bigger than negative 13. So the smaller is, so here smaller one is, that is negative 13, and we have to write its predecessor. It means we have to do the subtraction of 1. So its predecessor is that is equals to, so negative 13 minus 1, that is negative 14. So negative 14. Now for the second one, so we have 2 and negative 3. So we know that obviously negative 3 will be the smaller. So smaller is negative 3 and its predecessor is so negative 3 minus 1, that is negative 4. And the last one, here we have negative 4 and 2. So negative 4 is the smaller. So smaller is the negative 4 and its predecessor is, so its predecessor will be negative 4 minus 1, so that will be negative 5, right? So here we have the answers. So the first one is negative 13, its predecessor is negative 14. Then we have negative 3 and negative 4. And for the next one, we have negative 4, which is the smaller, and the negative 5, which is its predecessor. Now let's have the next question. What is the result of subtracting 0 from an integer? So if we subtract 0 from an integer, let's say if we have, let's take any one example. 7 we have. Now if we do 7 minus 0, we know that the result will be 7 only. So the number itself, that is option A, will be the correct answer. So option A, that's right answer. Now let's have the next question. Which property states that the difference between two integers is always an integer? So obviously that will be the option C, which is closure property, which states that the difference between or the subtraction of any two integers will result also an integer. So the correct answer for this is option C. Now let's see what we have discussed in this video. So we discussed about the properties of subtraction of integer. In that we discussed the closure property of subtraction, commutative law for subtraction, and also we discussed associative law for subtraction. Thank you.